Record. All right, that should be going. All right, I think we are up. So I'm guessing there's still some questions on PA2. So I had a number of students in office hours, and hopefully that answered some of the questions. But I'm guessing we're going to spend a good chunk of today talking about PA2. So I'm going to let you start with whatever questions you might have. And if we finish with those, then I want to talk about the previous ODP, the one that's due Saturday. And then we can go on and we can start talking more about Bash after that. But let's start off with whatever questions you have on PA2 or anything else.
I was just double checking. You said not to worry about the .o files in GitLab, right?
Correct.
Okay, and same thing for like a keywords.txt that we made ourselves.
Yeah, so the only thing that's required is your .c files, your .h file, and your make file. And if you have, test programs and those get included, that's not going to cause me any problems. Just make sure all of the pieces that you need to build the executable program, make sure those are in there.
Okay, thank you.
Oh, and someone uploaded this entire script of the Bee movie. Awesome. Where'd you upload it to? I think someone said the word bee appeared like, was it over 100 times? I don't remember.
It does if you count words that include be inside of them.
Okay.
But it's actually under 100 if you don't count those.
Just the word be. Interesting.
Thank goodness for random people on the internet that take the time to write all that down, put it in a gist.
I did have a brief question on PA2. I think I might have found a typo. I'm not sure if anyone's brought this up. In the function prototype for display results.c, it calls for a variable tally. Is that supposed to be count?
Yeah, if you try to name a tally in your main program, it's going to complain because tally is the name of a function. But the variable names in the function prototypes, you can call those whatever you like. And in fact, you don't even need to name the variables when you make a function prototype. I tried to put in variable names that were descriptive. And I probably should have called that count, because if you try to actually call a tally in the function, that's okay. But if you try to call that array tally in your main program, it'll complain. So yeah, that was overly confusing on my part.
Cool. Okay.
So for example, like string copy, there's two arguments. There's source and destination, but your strings don't have to be called source and destination.
Right, exactly.
Kind of renames it inside the function in a way.
Yeah. Yeah, so they're just kind of placeholders. The nice thing is when you prototype a function, it's sometimes nice if you put in descriptive names of the variables so that you can sort of use that as internal documentation, right? You can refer to your .h file if you don't remember the order in which the variable should go. If you've got two car stars, okay, this one's called file name, that one's called, error message or something. But the compiler actually ignores those names.
Right. Yeah, that makes sense. And then my only other question for the assignment was the index.h file and the make file. We do not have to comment those, right?
You do not need to comment the .h file. That comment block is only required at the top of the .c files. But you're able to comment the .h file, and again, just for kind of your own personal use, it's sometimes nice to put comments in the .h so that, you know, again, you can refer to just one file to see information about your functions, but definitely not necessary.
Gotcha. Thank you.
Yep.
I got a question.
Yeah.
So I got some updates for my main program index file. So I resubmit the index file in the GitLab. However, however, only the index.c got update, but index.o doesn't update. So I want to know what's the reason.
Did you add index.o?
Yeah, add index.o.
So hold on a second. Let me take a look at your repo here.
Yeah.
So you changed index.c, right?
Yep.
Did you recompile it?
I did.
Did you recompile it with a -c switch? So if you say git add star, it'll only really add the files that have changed. And so it looks like index.o was last created at 8:13 this morning.
Yeah, but when I update the index.c again, the index.o doesn't update it.
But if you say make, that should recreate the index.o. That should make a new version of index.o.
Okay.
And then if you do git add star, it should actually add index.o.
Okay, got you. Thank you.
Okay, welcome.
I had a quick question on the count thing. In the main
Yeah.
program, you had already had us declaring an int called count, and I used it in that whole while null does not equal get word for tally. And then I also used it in the display results instead of
Okay.
tally, and it seems to be
Good.
working just fine. That won't
Yeah, that should
cause
be
any
good.
like conflict. All right, awesome.
Let's see, index.h. So index.h, yeah, is just your function prototypes. So you know, in the beginning of your main program, normally you would say car star get word parentheses car star word close paren semicolon. So we put this inside you know, index.c. If we're not doing a .h file, we would put this inside index.c, and this is telling the compiler, hey, when you see get word, it takes a car pointer, it returns a car pointer. Instead of putting this in index.c, we can take this and we can put it inside an index.h file, along with the same declarations for my get car, tally, and so on and so forth. And then in index.c, in the very beginning, we say include double quote index.h. And what that's doing is it's saying take the contents of this file and include it right here in index.c. So if this is what's index.h, this is exactly like typing this right here. It just pulls it in and uses it at that point in the file. All right, what does it mean to process the input as we read it? I've only declared a car array for word and everything else works. That's probably fine then. What I don't want people to do is make an array of 1 million characters and read the entire file into that array and then start processing it. So that's what I'm asking you not to do when I say process the input as you read it. So as long as you're not making a big humongous array and storing the entire file in memory first, you should be fine. So yeah, to add your stuff to GitLab, go into PA2 and just git add star, git commit, git push origin master.
I had a quick question on the GitLab thing.
Okay.
My project should be good for PA2, but I manually deleted some of like the bogus test files that I made. And then when I
Okay.
went to just add it again, just as like a precaution, I got an untracked files from PA1 warning.
Right.
So any files, if they're like in your PA1 folder, it's possible that you just made some in your PA1 folder. And if they're untracked, it just means that they're not in Git, they're not attached to your Git thing. So if you want them attached, you need to git add, but if you don't want them, then you can ignore it, or you can.
Okay.
Yeah,
I had-
so you've got test files in PA2. If you don't add them to Git, it'll tell you that you've got files here that aren't in Git. And that's really all it's telling you.
okay.
Yeah, I've done a git pull and that seems to put that away.
Okay.
All right. And it won't like mess up my files on my computer or anything.
It shouldn't, but do you know if you're in doubt, you can always do something like this. And so I was telling people this morning in office hours, I was talking them through this. So you can say make dir tilde as your home directory / backup, make a directory, or give it some name, backup 20 for the 20th or something like that. And then copy asterisk into tilde / backup 20. And this will copy every file from your current directory into this totally new directory. And so, assuming you're in PA2, this gives you a separate copy of all your files. And if something weird happens, if your make file destroys a .c file, if Git decides to, do something strange and give you old versions of your files or something, this gives you like a nice local backup. So before you do anything really bizarre, right, you can just copy your files into this backup directory.
Okay, so in PA2, run that.
Yeah, in
here.
PA2.
Got it. Okay, thank you.
And then if you've simply created files that you haven't added to Git, git add, git commit will just say untracked files, and it's not a problem. It's just letting you know. If you cannot commit or cannot push because it says things are out of sync or fast forward or things like that, usually all you need to do is a git pull origin master and then a git push origin master. But this, it's possible that the pull might, give you an old version of a file. So make that backup first, just in case. And then the main way to avoid this is if you want to remove a file, do it through Git. Say git rm file. And if you want to rename a file, do that through git move old file name to new file name. And that keeps everything in sync.
And can we remove more than one file in one line?
Yeah. It's exactly like the RM command. You can put in wildcards and all sorts of stuff. But by doing this, it will remove it from the Git repository, and then it'll remove it from your directory itself.
Got it. Thank you.
Keeps things synced up. All right, let's see my get car question. What should my get car return if it receives EOF? So my get car, returns the next character from standard in or EOF at end of file. So it returns exactly the same thing that getChar returns. And if you've included standard io.h, you can actually just say return EOF. And that symbol is already defined for you. And then getWord can look for EOF and use that to say, hey, I've run out of characters. All right, cool. Other questions? These are all really good questions. Our class continues to shrink for some reason. All right, is that it for questions? How do we append a character to a car star again? Ah, excellent. So if you go back to the ODP for like the mix function, we had a trick in there, which was we were trying to build up an output string, and we were doing that by appending each character from the two input strings. So the first character of this, first character of that. The way we appended was we had an output index, which we initialized to 0. And to append something, we just copy it to out bracket that index and then increment the index. And so we can do the same thing in getWord. So assuming that we've got an argument, and I'm going to assume it's called word. And yeah, this should work fine. So output location equals 0. And do some stuff. And then when you want to say, you know, append character C to word, it's just word bracket output location. And we can do the increment right here, which increments outlook after we make the copy. So that puts C into word and increments the location. And then somewhere we're going along, and if we're about to return, right, if we're done, we need to add an null terminator. And so that's just word bracket output location equals single quote \0. And then we can return word. And so, yeah, that works for a car star as well as a car bracket. So let's talk about character arrays a little bit, because this is usually confusing for a while. Let's see, do you want us to write a specific number of keywords in our keywords.txt? So I'm actually going to use my own keywords.txt when I test. So it's really up to you. Use as many keywords as you need to feel like you're testing your code thoroughly. But I'll use my own keywords.txt and I'll use my own input file. But you're encouraged to test your code using the data under /temp/PA2. So there's a keywords file in here, and there's an input file. that goes along with it. So you can copy those and use those to test if you like. And if you include keywords.txt in your GitLab, that's totally fine, but I probably won't do anything with it. And if you don't include it, that's totally fine also. So yeah, you're welcome. Let's talk for a minute about this business of characters. Let's do this in code. All right, so let's look at the difference between car star and car variable bracket something. All right, so here's our first program, right? I'm doing a car star str, I'm doing an fgets, and I'm doing a print. And if I run this, I'm going to seg fault, right? And the reason I'm seg faulting is I told fgets, hey, there's 100 bytes available to store things into this string, but I have no reason to believe that there's actually 100 bytes available because I never said how big I want this array to be. I just said I want this to be an array. So if I say car star str, this means str is an array of characters. If I say car str bracket 100, str is an array of 100 characters. There's a subtle difference here, right? This is actually saying, make me an array of 100 characters. That's what I want str to be. This is saying str is eventually going to grow up and be an array of characters, but it's not usable as an array yet. I've said the type of thing it is an array, but it doesn't have a value yet. It's exactly like if I say int I, I'm saying, hey, I is going to be an integer. But if I try to print it, what is it going to print? I have no idea. There's no way to predict what it's going to print if I just say print I, if I declare it as just int I. Before I can do something meaningful with I have to give it a value. So if I say car add str, I have to give str a value still. Let's see, question in chat. So to copy FAQ and keywords, hold on a second. All right, so I'm in an empty directory, so I can say copy /temp/pa2/FAQ space period, and that'll copy it into my current directory. And if I copy keywords.txt into dot, that'll copy that into my directory. So those two copy statements will do it. And then you can run your function and say less than FAQ, and it'll read that as input. You're welcome. All right, so let's see what's happening in here. So car star str says str is going to be a character array. But let's go ahead and print out what the value of str is. So when I do this, it says the value of str is, and it says nil. Right? Nil is another word for null, which is usually another word for 0. So since str is 0, right, it's pointing to memory location 0. If I try to use that in fgets, I'm going to get a seg fault. So if I instead do something like car str bracket 100, and I run this, now the value of str is, and it's something different from nil. It's something that looks like a memory location. Right, this is a 64-bit machine, so this is a 48-bit number. It's actually a location in memory where this array is being stored. And so that's what's being passed to fgets. And presumably there's 100 bytes available and writable starting at that location. So now I can say hello, and it'll tell me the value of str is hello with a new line.
So if you don't show that's an array and you show how big the array is, it doesn't reserve the memory.
Exactly. It doesn't reserve the memory, and it doesn't set str to anything in particular. So it might come out nil, it might come out some random value, but it's certainly not going to point to somewhere where there's 100 bytes totally available and free to use. So in my main program, right, I need to do something like this. But now let's call a function. So let's make a function called myPrint. It's a simplified version of display results. So suppose I say myPrint str. So inside here, I've got a car star s.
Display
And I'm going to do the thing that got us into trouble before, which is just a printf. But this is not going to cause problems now, because this argument is coming from this thing that's being passed to myPrint str, and up here str is declared to be an array of 100 characters. So there's space being set aside, str is being told to point to that space. And then when I pass that to a function, all I need to do here is know that s is a pointer to a character, but the value of it is going to be whatever's up here. So if I print out the value of that arg, right? So I print out the value of s is, right? So the value of string was this, memory location address. I typed hello, it called my print, and inside my print, the value of that argument S is exactly the same thing as the value of str. So the punchline kind of is that, somewhere along the way, somebody has got to say something like, car string bracket 100. Somebody's got to make sure this thing actually points to a location in memory where there's space available. And since my main program is doing it, my main program is passing that array to a function, the function does not need to do that. And so our tally function, our read keywords function, our get word function, right, can just declare arguments to be car stars. And the space for these is actually set up in the main program. Now we did something different with read keywords and with tally. I said you can go ahead and you can actually declare these things with arguments car keywords bracket 100 bracket 32, and that's because these are two-dimensional arrays, and doing this same kind of business with a two-dimensional array gets trickier, and so it actually makes things simpler to just hardwire the dimensions. But for a general thing like fgets, for example, we don't necessarily know how big this array is, and so inside fgets it declares this argument is just a car star. Let's see, for testing the index program, document says use /temp/index. Yeah, that is a typo. Thank you. So yeah, if you go into the PA2 directory, it's just index. If you do this from outside, then it's /temp/PA2/index. I will fix that on my copy right now, but I'm not going to change it in the upload because I don't want to extra confuse people. All right, other questions? So I'm probably not going to be emailable this afternoon or tonight. I do have office hours tomorrow starting at 7:30. But if there's anything that you're not clear on, this is the best possible time to ask about it. What about read keywords? Why does it work? You mean, why does it work with the brackets?
No, I think I missed something about opening files in a previous lecture. And
Oh, okay.
so that whole thing is still kind of a mystery.
Ah, okay. Let's see. So read keywords. And let me see. So you run the function by giving it the name of the file you want to read in this keyword array. And so in your main program, index.c, you're going to call this with keywords.text, but you could pass it any file name that you like. And the whole trick in here is to use fopen. and fopen takes two arguments. The first is the name of the file, and the second is the way you want to open the file. So you can check the manual page, right? So it takes a path name, it's a car star. So it's just a string that says what you want to open. And then the mode is also a string, so it goes in double quotes. And if it's an R, you're opening it for reading, which is what we're interested in. And it returns a pointer to this thing called a file. So we usually say something like file star, and you can call this whatever you want. FP is short for file pointer, equals fopen. That opens a file and it gives you access to its contents. And then we can just use fgets with a character array, the size of the array, but instead of standard in, we put that file pointer. And then instead of doing an fgets from the keyboard, it'll do it from this file. So that's one of 3 points about reading from the file. The second is that at the very end, you want to do an fclose on FP, which undoes the open. And the third is after you open a file, you have to check to see if it succeeded. So if FP is null, you've got an error. The file couldn't be opened or it didn't exist. And so for us, in read keywords, we just return -1, and that's the flag. Does that help?
Maybe.
And then inside the code itself, we can do another while loop, like while fgets is not equal to null. Because fgets, remember, it returns null when you hit end of file. And so while fgets is not null, basically we're going to string copy into keywords bracket something, comma, str. So which element of our keywords array do we want to copy this word into? Well, it depends how many words you've read.
Why
So-
100 in the middle of the fgets
Of
statement?
here?
Yeah.
That's just the size of the string. So it has to be at least 33. And if I just need a big string, I just make it 100. But it's kind of a random number. You could make it 50, you could make it 33. But don't make it, like 5, because if you get a word that's got more than 4 characters, it won't have enough space to store it. But I'm assuming that I did some car str bracket 100. So fgets is the safer version of gets. And it just takes 3 arguments: a character array, the size of the array, and then where you want to read from. So for this example, I was just assuming that's the array, that's its size, and that's the file we're reading from. And so where do we store it? Well, set up some kind of counter, right? So initialize some index to 0, store your first string in element 0 of the keyword array, and then increment that counter. So the next time I read a word, it'll store it at keywords bracket 1, and the next time keywords bracket 2, and so on. And then the other things you want to do in here is remove the new line from the end and convert to uppercase. And converting to uppercase, you can do that with a for loop. Go through each character of your string and use the toUpper function to convert it to an uppercase letter. let's see, what would be my input file to execute the sample program against our own test data? So you can test this program a few different ways. So here's my program. So I can say index. I can just type things on the keyboard and then hit a Control D and it'll go ahead and run. But if you have a larger set of test data, especially something that you want to keep using repeatedly, you can put that inside a file. So I could make a test file. And then I could say index less than test file, and it'll run against that file instead of having to type that in, or the B movie script. And so it's easier to work with a simple file, right? So you could make a simplified set of keywords, and then an input file that has 5 or 6 words in it, or maybe a few lines, and then use that. And you can also try this, right? So if you make that your input stream and you make your keywords, hello, this is fun. It should find hello once, this once, fun once, and it should not find the word is. And then when you think everything is all set up, you can try it against this keyword file and this input file. And that's a pretty good test case. If people can't copy that file from your directory, it may be because your home directory is protected, but you could copy that file to /tmp. And then people can just copy /tmp/test input.txt. And then it's like publicly available. Cool. All right, other questions? Yeah, so those are there exactly to help you try to match the sample code. So if you do yeah, so you can copy FAQ and you can copy keywords.txt from /temp/pa2 to your directory, and then just run your index less than FAQ. So let me do this. All right, so there's my index program. So I can copy /temp/pa2/ frequently asked questions into my directory. And I can copy temp pa2 keywords.txt into my directory. And now I can do index less than back, and there's the results of my index program. And then I can go into /temp pa2, and in this directory, there's my copy of index, and I can say index less than fac, and I should get the same results. And if that works, you're pretty guaranteed that the program is behaving correctly. And then the only unknown is, did I implement these functions in the way that I was supposed to? Does display results take this kind of thing, this, and return void? Does get word actually return EOF at the end, and so on and so forth? And do I have a make file? All right, what else?
Is there a way to copy like your FAQ and your keywords.txt directly into your own directory? Or is there just kind of no way to do that? Because, you know.
That's this stuff. So those two lines should do it.
Thank you. Sorry.
That's okay. Yeah, just do this from the directory you want to copy them into, and dot means current directory. So that'll put it in there.
Cool.
Yeah.
My get car is supposed to read from what exactly?
Standard in.
Which means typed.
Which usually means typed, unless you do this less than thing. If you do this less than, then it's going to read from this file. But if you use get car, right, this built-in function, that reads from standard in. And so you don't have to worry about, you know, how do I know if they redirected from a file or anything like that. If my get car simply uses get car, it'll read from standard in, because that's what get car does. So inside my get car, you want to read a character from standard in, which is what get car does. So get a character, and if it's a space, return a space. If it's end of file, return end of file. If alpha, return to upper C. Otherwise, try again. You got a digit, punctuation, something, get another character and return either a space end of file or the uppercase version, or go back and get another character.
So if I used recursion there, would I end up with problems if I got a file full of periods
I
or
would
something?
not suggest recursion.
Okay, well, then I gotta go fix that.
Yeah. That's a slick way to do it, but it can get very deep and you can potentially run out of memory that way.
What's the last line? Is
Else.
something? Oh, sorry.
Else. So this whole thing has to go in a loop, and basically you need to keep getting characters until you get a space, an end of file, or an alpha. So if your character stream looks like this, right, you're going to read the exclamation mark. It's not any of these. I'm going to go back, read again. That'll give me the 1. It's not any of these. Go back, read again. It's not any of these. Read again. It's not any of those. Read again. Then when I read the X, it'll say, oh, that's an alpha. I'll return an uppercase X. And that's the end of my get car. All right, let's do a 5-minute break. And when we come back, if there's no further questions, we'll talk about ODP 402, and then we'll start talking about scripting some more. So let me put a timer up. And let's come back at 11:02. All right, we can start with that question when we come back. All right, let's see, what else do we got? How can we call get word properly in the index function? So index is our main program. And so we need a character array, right? Get word is supposed to be given a character array that it will load a word into. So in our main program, we need to actually declare the space for that word. And then to call get word, we can say get word, parentheses word. And it's possible that, we're going to hit the end of the file when we do this. And so we need to check the return value from this. And one way to do that is to call this function inside the condition of our while loop. So here's a pretty typical way that we use fgets, which is kind of what get word is doing. Well, get word is not equal to null. And I'll put a comment here. Word is the next word to tally. So this is one of these while statements that does three things. It calls get word, right? Which will load a value into this variable word, this array. And then it will check to see if get word indicated end of file. And if it did, it will exit this loop. And if it didn't indicate end of file, it'll go ahead and execute the body of the loop. And so here we can say call tally. And in the beginning, we initialize by calling read keywords. And then at the end, we call display results. And that should display the data. All right, so I had a question about printing keywords after you answer that. Yeah, go for it.
It was pretty much just how you would print the keywords in display results. I just kind of wanted to see a rough idea of that because I was working on it this morning, but I just didn't have it completely narrowed down yet.
Are you asking about the C code to do it, or are you asking about the formatting that's expected?
Formatting.
Oh, not terribly picky. So I think the description says keyword followed by a colon followed by the count, the value of the array. But you can run the sample code and just something like this, keyword colon and the count. I'm not worried about spacing or things like that.
Okay.
Yeah, it's not auto graded, so.
Okay, cool. Thank you.
Yeah, you're welcome.
Could you also actually dive into the code a little bit as well, like the pseudocode of it?
Mm-hmm. So display results gets three arguments: keywords, the tally, and the number of words.
Okay.
So keyword, let me call it count, and the number of words. So if numwords is 5, we've got 5 keywords, and we can get to those as KW0, KW1, all the way through KW4. Right. So even though keywords is a 2-dimensional array of characters, it's also a 1-dimensional array of strings. And so we can access each string as keyword bracket a successive index. And so we can do something like for I equals 0 to number words -1 because we're starting from 0. And we can print keyword bracket I and a quote and or a colon and count bracket I. And that's pseudocode, but that's the gist of it.
Okay. Yeah, it's not too hard. Thank you.
Okay, welcome. All right, well, let's take a look at the ODP. And so this is due Saturday morning instead of Friday. And so ODP 402 is a bash script. So these next few ODPs are going to be bash programs rather than C programs, because PA3 is going to be a bash program. So is PA4 and 5. So for this one, you're writing a script that basically lets the user type a number, multiplies that number by 2, and prints it out. And this ODP is auto-graded, so the formatting is really, really critical. So I called my ODP good program, but here's what your program should do when you run it. Hit an enter. It should not type anything. It should not prompt you. It should not say, you know, welcome to my program, please give me a number. It does nothing. It just waits for you to type a number. And whatever number you type, you hit enter, and it prints out that number multiplied by 2, and it exits. And it's got to be exactly like this. If it does anything else, if it says, you know, the answer is 66, it'll assess for 0 out of 10. So bash script, since we're not doing C functions anymore, the formatting gets really critical. So read one line of input from the user, treat it as an integer, multiply by 2, print it out, and you're done.
So when you are like making the files for these, it's just like VI ODP 402. There's no like dot anything.
Correct. Yeah.
Okay, cool. Thank you.
Mm-hmm. And so let's do this. Let's make an ODP 402. So you remember what the first line of your bash script always has to be? The shebang. So the number sign exclamation mark /bin/bash. And then we can put in whatever statements we want. And in this case, we want to read something from the user first. So what's the bash command for reading a variable from the user?
Could you just do like read variable name?
Mm-hmm. Exactly. So we can say read, I don't know, I'll just call it argument. And so I'm just going to build up to the whole ODP. I'm going to read an argument, and I'm just going to echo its value. I'm going to say arg equals, and I'll say $arg, which means show me the value of this variable. So if I try to run this, I'm going to get an error. It's going to say permission denied. This goes back to the permission bits. So right now my file is readable and writable by me. I cannot execute it, and nobody else has any access to it. So do you remember the command for changing the permission bits? Yep, change mode. And so most often we're going to use one of the following. If we use 755, that's going to give us read, write, and execute permission. It's going to give everybody else permission to read and execute, but not modify. So if we're making a public file that we want other people to be able to execute, 755 is a good way to go. If we want to be super secret, we can do 700, which gives us read, write, execute, and gives nobody else any permissions at all. And if I want to make a file that I can read and write, but not execute, and I want other people to be able to read it, but not write it or execute it, we could do 644. And that gives me read, write access and gives everybody else read only access. And remember, the way that these octal codes correspond to these permission bits, is these permission bits are basically making a 9-bit number.
Sorry, you said the 755 gave everybody permission for reading and writing and executing?
This will give me permission to read, write, execute.
Mhm.
It'll give everybody else permission to read and execute, but not write.
Okay, cool, thank you.
And that's kind of the default for most executable files on the system. Yeah, you're welcome. So for example, if I do a ls-l on /bin, most of these files are 755. So vdir, whatever that is, the owner, who is root, can read, write, execute. The group, who's also root, can read and execute, and the rest of the world can read and execute. So I can't remove /bin /vdir because it's write protected. All right, so right now my default is no execute permission. That's true. But you can also do these octal conversions by hand, because you can do them digit by digit. So that's a 6, that's a 4, that's a 4, that's a 7, that's a 5, and so on. And so you only need to know the binary representations for 0 through 7. That's cool. I'll do a pitch here for my favorite calculator app. So I use this app called Real Calc, and I've been using this for years. And I just use the free version. They ask me for money every now and then, and I always feel guilty, but I don't do it. But this is nice because you can change the mode to like octal and say, 755, and then go to bin and see what that is, and so on and so forth. But it's a really good calculator program. I highly recommend it. I think it's just called Real Calc. Yeah. So I like them. All right, so let's make our program executable. And I'm just gonna do 755. And so now I should be able to execute this, and it's executing this read arg statement. So I can say ha ha ha, and it says arg equals ha ha ha. All right, so we've got input. That's the start of all good things. So for the assignment, we need to take this argument and multiply it by 2. So do you remember the trick in Bash for doing arithmetic?
No.
That's an answer. That's fair. Yeah, so $, paren, some expression, double close parens. This will evaluate this as an arithmetic expression. So I can say something like echo 2 plus 2, and it just says 2 plus 2. But if I echo $, paren, 2 plus 2, it gives me a 4. So let's add 1 to arg. So I'll say arg equals $, $arg plus 1. No, I'll print out the new argument. All right, so ODP 402. So I'll type in the number 12, and it tells me argument equals 12. I'm adding 1 to that. New arg equals 13. So we've got a way to do arithmetic.
So could you actually like instead of like replacing arg like that, could you just echo $paren arg plus 1 and it would like do the same
Absolutely.
thing? You can? Yeah. Okay.
Mm-hmm.
I know you said this language is kind of like picky. I was just kind of curious, like how picky is it gonna be?
So let's add 10 to it. So I'll give it a 12. It comes back with 13, and then this echo statement printed out at 23. So if we want to multiply by 10, it's just *10. And if we want to say divided by 3, we can just do arg/3. So I'll put in the number 100. Add 1, it's 101. If I multiply by 10, it's 1010. If I divide arg by 3, 100, I divided by 10. 100 divided by 10 gives me 10. Well, let's divide by 3. So you get the idea.
Is Bash pretty picky about like returning like floats and stuff like that?
So these are really just strings, and when we do $paren, they turn into integers. So if I do something like haha, it'll treat that as a 0. But if I do something like 2.5, it'll get all kinds of bothered because it doesn't know how to do 2.5 plus 1. So for this ODP and for a lot of what we do, we're just going to assume that the input is exactly what it should be. If you're supposed to put in an integer, you're going to put in an integer. And it gets pretty bizarre trying to clean up input. In C, we can just use scanf. It's a little trickier in Bash, but we're just going to kind of not worry about that for now. And for comments, we can use a number sign. And we can use white space as usual, just to separate, sections of code out. And we can indent if we like, and so on and so forth. So spaces in the beginning of a statement are totally fine. We can do anything we want with those and it won't change the program. And we can put spaces in between statements, but we have to be really careful about spaces like right here. If I put that space before the equals sign, it's gonna freak out. So spaces inside a statement have to follow, you know, whatever the convention is that we're following, but we can put them before, and we can also put comments afterwards. Like that.
So basically what you're saying is like the habits of writing like I space equals space one is gonna just like throw everything
Yeah.
off.
That's gonna freak it out.
Yeah.
All right, so for 402, you multiply your argument by 2. So, you know, something like this. Get rid of all the extra echoes and so on and so forth, and you should be good to go. All right, good on 402. All right, so back to read keywords. The other business with reading the keywords is getting rid of the new line at the
Actually,
end.
I figured this out,
Okay.
but I did have one last question.
Yeah.
How do you connect our index executable to the keywords.text in wherever you have it? I was
Copy.
using my own, but I think I'm ready to try the built-in one.
So just copy from /temp/pa2/keywords.text, copy that into your current directory. And it will use whatever file it finds in your current directory. So if the one in your directory is the one from the test area,
Got it.
that's what it'll use. Does that make sense?
Yeah. Thank you.
Okay. Yeah, you're welcome. All right, well, so we've done a program that will read from the user while the program is executing, right? So this read statement basically says, hey, stop executing the program, wait for the user to type something and hit enter, and whatever they type, let's put that in arg. So let's make a different program. And so here's a program we did before. Right, so this says read a name and then say hello name. So I'll make this executable. And if I say test2 Nick, it says, sorry, if I say test2 and I type in Nick, it says hello Nick. If I say test2 and I say ha ha ha, it says hello ha ha ha. So this is what we call the runtime input. Way back first week of class, we talked about runtime inputs and command line inputs. This was a runtime input, which means that when your program has already started running, I've typed the name of the program and hit enter. After that is when it's going to ask me to type in some input. The alternative is to have a command line input. And with a command line input, I would type the name of the program. And on that same line, before I hit enter, I would type an argument. And I want to modify this program so that if I do this and I hit enter, it just comes back and says, hello, Nick. So it's processing an argument from the command line instead of this runtime input. And that turns out to be really easy to do in Bash. So in C, we do that with argc and argv, right? In Bash, we have this variable $1. And $1 is a variable that holds whatever we put on the command line. So if I say hello, $1, now if I say test2 Nick, oh, and get rid of this read. Now it says, hello, Nick.
So is one just like the equivalent of, like argc, rv kind of stuff? It just signifies like take command line input.
Yep. So this is basically argv bracket 1 from C.
Okay, interesting. And it's just the number 1 with a $sign.
Yep. And so if we say also hello to $2, well, $2 didn't exist. There was no second argument on the command line. And so it said, and hello, and $2 was blank. So if I say test2 Nick, Phil, it says hello, Nick, and hello, Phil.
I see. So like if it was like just a 3, you'd have to put 3 in and it would ignore the first 2 and just give you the third one.
Exactly.
Okay, nice.
So these are nice to be able to use. So these are the command line arguments. And if I put things inside double quotes, they get treated as a single argument. So if I just said, hello, this is all one arg, this would be $1, this would be $2, this would be $3, and so on. But if I put all of this inside double quotes, this whole thing becomes $1. And the quotes say basically group all this together, even though there's spaces in the middle. So now it says, what is called test2. So now it says, hello, this is all one arg. And there is no $2, right? This was all the first argument. And if I say test2 star, it's going to do something a little bizarre. It's going to say hello ODP 402 and hello test2. Do you remember why that's happening?
I'm guessing those are just saved somewhere as like the first 2 arguments. No?
Not exactly
No?
saved.
Okay.
They're wild cards, right? So
Mhm.
it would be anything in the directory, right? And I'm assuming it would just go, well, how would it label them like first to last?
It alphabetizes. So these are the files in my directory. When I type in any command with an asterisk, Bash will take that asterisk and look for files in the current directory that match that. Since an asterisk matches anything, it basically creates a list of 2 words, ODP 402 and test2, and it replaces that asterisk with this. And so when I say test2 star, it's exactly the same as if I had said test2, this stuff. And so it prints out the first argument and prints out the second argument.
What's like
so-
the practical use of that? Like, why would you ever kind of just need to scan through your entire directory like that?
Oh, let's say I wanted to change the permissions on every file in my directory to be 755.
Mhm.
Right? So I could write a script. Oh yeah, well, someone just said in chat, git add star.c. So that's a
Could do
simpler
that,
example.
yeah.
And then bash will replace this with, you know, a list of names of all files that end with a .c. And then when git starts executing, it sees git add, you know, index.c, getword.c, my getcar.c, and so on.
I see. I've seen these commands before. So basically we've learned some bash commands without realizing what we were
Yeah,
learning.
yeah,
Yeah, okay.
totally. All right, so let's do this. We start from 1 instead of 0 with bash, which is interesting. And so it kind of matches argv in that way, because argv bracket 0 is the name of our program. Argv bracket 1 in C is the actual first command line argument. So if we add a few more variables, we can see our arguments are, this is a test, and $5 is just missing. So the next question is there a way to tell how many arguments we have? And we can't really just say, you know, let's find a place where $something is blank, because I could say test2, blank. This has more stuff. And, you know, $2 is missing, but that doesn't mean that that's the end of my list of arguments, because I still have a $3, 4, and 5. So we need something else. And the answer is just another variable $number, which tells us the number of arguments.
So if a hashtag's not at the beginning of the line, it won't count as a comment.
Yeah, if it comes right after a $, it's treated as this special variable. Go figure, you know. This is something that's easier to do in interpreted languages like Bash. You can have all kinds of rules that don't really follow a totally consistent pattern, and that's fine. So test2, this is a test, $number is 4. If I just say test2, $number is 0. If I say test4, this is a test inside quotation marks, $number is 1. If I do test2 star from my parent directory, which has a lot of files in it, $number is 19. Because in this directory, I have 19 files. All right, so $number is useful. $sign is an interesting variable. So if I echo $sign, I get this kind of bizarre number. But over here, if I echo $sign, I get a slightly different number. And this turns out to be your process ID. So this is a unique integer that identifies your particular process. In this case, what's the process that's running? It's a program called bash. And it's currently executing, and it's waiting for me to type in a command. And if I use the PS command, I can see, yeah, there's a command named bash running, and its process ID is 57057. That's what $$ is giving me. And over here, if I do a PS, I see that I've got a bash command with process ID 56818. That's what $$ is giving me here. So this is a little bit of an ego. It's a little bit of a way for a program, a bash script, to know something about itself, to know what its process ID is. All right. Another useful command is, or variable, is $? And do you remember what this was? I think we touched on it briefly once. So this is the return status of the previous command. So if I echo $? It's usually going to be a 0. And most of these commands, you know, they're programs, they're written in C. The main program is usually int main, parentheses, argc, argv. And so when the program exits, it's because it does a return statement. And the value that most of these programs return is a 0. 0 means everything worked great. But if I say something like, you know, cat some file that doesn't exist, well, the cat program noticed there was an error. I tried to look at a file that did not exist, and it returned with something other than 0. So if I echo $? I see a 1. And that 1 tells me, hey, something went wrong with the cat program. Now, if I echo $? Here, I get a 0. Why? Because the previous command was echo, and echo did not encounter an error. And so this is showing me the return value from this echo command.
So could you use this to somehow mix Bash and C programs into
Absolutely.
like one overarching program?
So let's make main.c. So here's my silly main program. All it does is return a 19. And if I go ahead and I run this, and then I look at $? Guess what? It's a 19. So I can return a short piece of information, namely a short integer, 8 bits, from a C program, and I can access that return value from Bash by just looking at $? Now, usually this is used to indicate the success or failure of a command or a program. And so most programs return a 0. But for example, let's say grep main, let's search for an int in main.c. So grep is a search program. It searches this file for whatever this string is. And if I search for an int inside this file, and then I echo $? I get a 0. Now, if I search for a string that's not in the file, it doesn't show me any lines because no lines contain INTT. But if I look at $? It's non-zero. So grep returns a value that tells me, hey, did it match anything or not? And so different commands have different meanings to what they return. And if you write your own program, you can return whatever you like. So your index program, right? Don't do this because it's not part of the requirement, but you could write your index program so that returns 0 normally, but if it gets an error where it can't open the file, it could return a 1. And then somebody using that would have a way to use it in a script and know whether it succeeded or not. So that's $? And we'll use that a lot more in some of our future assignments. All right, so those are the main ones that we need. In particular, we need these ones up on top for dealing with command line arguments. All right, is that good?
And the if, for, and while loops, whatever you want to call them, that's on Canvas, right?
Yeah, so there's a guide to bash conditionals. I forget exactly what I called it, but let me show you which one you want. So it's a document that starts like this. And this describes the exact required syntax for doing loops, conditionals, arithmetic expressions, and so on. So while loops are while, bracket, bracket, condition, do, statements, done. If statements are if, bracket, bracket, condition, close bracket, bracket, then, statements to do, and fee. Or you can do an else, or you can do an else if. And then the conditions, depending on whether you're comparing strings or numbers, two different formats. For strings, you use double equals for equality, exclamation mark equal to see if they're different. And for numbers, you use these tags for equal, not equal, greater than, greater, equal, and so on. And so there's examples of each of these. Don't use quotation marks for comparing numbers. And if you have multiple conditions that you want to do ands or ors, you can do double ampersand or double pipe to string those together. And then for arithmetic statements, it's a $ paren. And I'll make the warning that I made yesterday's in class and that I say here. Try to just totally avoid using plus plus and minus minus with bash. They work, they're great, they're a little bit shorter to type, but more often than not, they get people in trouble. Because if you do something like this, it's not going to do what you think it will do. So, and yeah, there's a link to this in Canvas. Let's see. All right, so good on that. So, two comments about strings and PA2. One, when you're building your keyword array, right, we use string copy, keyword bracket I, comma, whatever you read into, right, rather than just assigning with an equal sign. Because str, if it's a string, it's actually just a location in memory. KW bracket I is just a location in memory. And if we use an equal sign, it doesn't actually copy the contents from here to there. It changes this to point wherever that's pointing. So we use string copy in there. Similarly, in our tally function, we don't want to compare strings by using equal equal, because equal equal will almost always be false. If these are different strings, if this is a string in your keyword and this is a string from get word, right? Those strings may contain the same characters, but they're different strings. They're stored differently in memory. And so what you want to use is if string compare S1 comma S2 is equal to 0. And if string compare returns 0, it means they match. So you have to do it like this instead of that. And if your tallies are coming out 0, it may be that you're doing that. Or it may be that you still have new lines at the end of your keywords. Yeah, memcopy is part of string.h, so that's legal to use. That's fine. Cool. All right, well, let me talk about one more thing. If tally is still not tallying up, throw some print statements into your tally program. And as you go through the keyword array, I suggest printing out each keyword and printing out the thing that you're comparing it to, and print each of those like this, right, as a %s inside angle brackets. And, put in explicit print statements. So, print a message like, inside tally, index equals, say what the index is, keyword bracket index equals this, word that you're comparing to equals this, and then look at your output. And if you see something that says, index equals 2, keyword bracket index is hello, word I'm comparing to is hello, right? If you see that, then it really should be incrementing the tally. And so look at where you're doing the string compare, put some print statements inside that, see if it's finding that they're equal, and so on and so forth. If there's a problem with the keywords or with the word, if maybe the word has an extra space at the end or something like that, you'll see a message like, keyword equals angle bracket hello angle bracket, word I'm looking for is angle bracket hello space angle bracket. That tells you right there, okay, I've got an extra space at the end of what get word is giving me. So you can drill down into the behavior by doing those kinds of debug statements. And that would be my suggestion for finding out what's going on. You don't need to zero out the keyword array, because you're going to load each keyword by using string copy. But the count array you can initialize just like this: integer count bracket 100 equals curly bracket 0. And that'll do a compile time initialization, so that when your program starts, this contains zeros. Memset works, but it happens at runtime, and so it's just a little nicer to do it at compile time. Right, exactly. All right, so let's talk about something related to what we've been doing with PA2. This is something we'll get into more in winter quarter, but let's talk about this business of passing variables to functions and passing them back. So I'm going to say, before calling inc, I equals %d. And then I'm going to call my inc function. And I'm going to say, after calling inc, I equals %d. All right, so what is my inc function? It's just going to take an argument and increment it. If nothing is printing, then you're not getting into your function. And so maybe your get words is returning null and you're not noticing it, or maybe get words is not returning null. So this might be a good, you can either add more print statements to your main program, or you can try to do this in GDB. But put in some more print statements, right? Your main program has a read keywords, it has a loop where it reads words and tallies, and then it has a display results. So throw in some print statements around each of those sections and see how far it's getting. And it's probably getting hung up somewhere. And my first guess would be it's not exiting when get words finds the end of the file. So keep adding debug statements. All right, so here's a function called inc. It takes an integer, and the goal of this function is to add 1 to the integer. And so I'm going to set I equal to 5. I'm going to call inc I, and I'm going to print out the value of I before and after. And you can probably guess what this is going to print when I run it. That's a lot of errors for a 16-line program. So I forgot a curly bracket somewhere.
You forgot the opening quotation.
I forgot the
marks in
quote.
index statement.
Thank you. That's a little better. Thanks. All right, so we'll go ahead and run this. And, you know, before calling inc, I is 5. After calling inc, I is 5. So, you know, even though to someone who hasn't been doing C as much as we have, this might look really mysterious, we probably have encountered this before, right? The fact that when I call inc with an argument, changing that argument doesn't change the variable that I passed to the function. And the reason for this is 3 words that haunt a lot of people. The 3 words are pass by value. And here's what pass by value means. All right. When I say inc I, so my program is executing, it sets I equal to 5, it prints this out. Now it's about to call increment with an argument of I. Here's what the code does as it executes. It looks at the current value of I, it sees that it's a 5. This is what it does. It does inc 5. It passes the number 5 to this function. And if you think about this, if I were to just write my code like this, you'd have no reason in the world to imagine that I would change value, because I'm not even mentioning I when I call this function. I'm passing the number 5. And in an Alice in Wonderland kind of world, you know, 5 might change into 6, but that fortunately does not happen. But certainly I is a 5 before I make this statement run. I is going to be a 5 afterwards. So even though I put an I in here, this function does not actually get the variable I, it gets the value of the variable I. And that's what we mean by pass by value. It means we take the current value of that variable, that's what we give to the function.
How do you print an array? I'm trying to figure out to look at keywords itself.
You can print each element in a loop. So make a for loop and go through each element and print each one. Oh, and let me mention something else with debug statements. When you do prints, always, always, always put a new line at the end of every single debug print statement. That's not just to make it look pretty. If you don't put a new line, your print statements don't actually get printed right away. And so if there's an infinite loop and you're trying to print something inside the loop and there's no new line at the end of the print, you won't see those statements being printed. So the \n flushes the buffer out. So when you're doing those prints, always put a new line there. All right, so this is passed by value. We're passing I, but it's not actually like arg is a replacement for the variable I. Now, if we want to be able to change the value of our argument like this, then we have to use pointers. So we can say integer star I, or well, we could say integer I. We could pass the address of I. And down here, we could say that we're going to take a pointer to an integer. And we could say the thing that arg points to, let's add 1 to that. Let's store that back into the thing that arg points to. And we'll change our prototype to say we're going to pass a pointer to an integer. And now if I run this before calling inc, I is 5, after calling inc, I is 6. So when we have an array, what is an array? It's a pointer, right? So if I have something like integer data bracket 10, and I say data bracket 0 equals data bracket 0, and let's initialize this to 5. And let's just call inc data. And down here, I'm going to say arg bracket 0 equals arg bracket 0 plus 1. So I seem to have gotten rid of my ampersand, and I got rid of my stars down here, and so on and so forth, but they're actually still there, right? Because when I say integer data bracket 10, data by itself, just this word data, is a star int. And so when I call inc with data, I'm actually passing a pointer to an int. I'm also passing the address of the first element in that array. And down here, I'm saying I'm getting a pointer to an integer, but that also means that arg is an array, and I can say arg bracket 0 to access the first element of that array. And so if I run this code, it does exactly the same thing. I passed a 5, it came back as a 6. So what's the wrap up here? If I just pass an integer, it's passed by value. I can't modify it in my function. But if I pass an array, it seems like I can modify it. And the reason why I can is because when I pass an array, I'm actually passing a pointer to an int in this case. So this is why things like getWord can modify the argument, right? You call getWord and you pass it a character array like this. And inside our function, it makes changes to this argument. And when we come back to our main program, this word has changed, right? Well, that's because it's a pointer to a character. So there were some questions about that over the past few days. That's basically the story with that. All right, any other questions?
So the passing an array to a function is kind of just a side effect of the data structure of the array?
It's sort of, yeah. I mean, it's basically because so down here, if I tried to change arg itself, I would fail, right? So I'm passing data. Down here, if I say something like arg equals arg plus 1, data is not going to change, right? But data is not the actual integers in the array. Data is a memory location. It's a 0x7ffff, blah, 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 right? But it's pointing to 10 integers. And when I do this, I'm saying, let's look at the thing that this argument is pointing to. let's take that value, add 1, and then put it back at that same location. And so it's really just another pointer. And like I say, we'll dig a lot more into that in CSE224 in winter. But it's something we can kind of live with for now without really understanding why it works. But we can start working towards understanding why it works. All right. Anything else? So I will try to post some more ODPs over the weekend to work on next week. I will try to get PA3 together and talk about that on Tuesday. And we'll also talk about the midterm on Tuesday. Remember, the midterm is a week from today. So we'll talk about what to expect on that on Tuesday. And then we'll continue digging further into Bash. All right, that's all I got. So let's see. Office hours tomorrow morning at 7:30. So 7:30 to 9. All right. I will let you out of here then a minute early, and I will catch everybody next time.
Can I ask a question?
Yeah.
My question is about GitLab. So can I share my screen? It's not about code. It's about my GitLab.
Okay. Yeah. Hold on one sec. All right. Go ahead.
Okay. Thank you. So you could see the index.c. Just like I say, I want to like update my code, but when I update my code, only the index.c get update, but index.o never get update.
Did you change index.o?
Are they the same?
So you edited index.c, right?
Yep.
Did you edit index.o or change it somehow?
No, I didn't change index.o. I think I thought they are the same.
So if it doesn't get updated, it doesn't push it over. So it's only going to push over things that have changed.
So how do I change index.o index.o?
Do you need to change it?
So I got a little bit confused. So when you download my code, are you going to download my index.o or index.c?
I'm going to look at your index.c, and then I'm going to compile it to make index.o. So I'm never going to use your index.o from GitLab. It's okay if it's in there, but it's not something that needs to be in there.
Okay, so it's okay for me index.o never get changed, right?
Yeah, that's fine.
Okay. Because when I update the index, when I upload the index.c again in the GitLab, index.o doesn't do anything.
Yeah, that's okay.
So why it looks like this? I got confused.
Why does it look like what?
Why it looks like this? When are they the same? Index.c and the index.o, are they the same?
No, index.o is the compiled version of index.c. So go back to your Linux machine
Okay.
and let's see what that screen looks like.
I just use
Say make.
make. Okay.
Yeah.
Make.
No, just make.
MAKE.
Lowercase. Yeah.
Okay.
Okay, so that compiled index.c. See where it says GCC-C index.c? See that first line it printed?
Yeah.
So that's compiling index.c. That gets you a new index.o. So now say git add star, git commit, git push.
Git
Git push origin master. And now
then-
go over to GitLab and refresh the page. And
Still the
so
same.
index.o, oh, 3 hours ago.
Yeah. That's
Um,
weird.
Interesting. So it didn't change for some reason.
Yeah.
That's okay.
But my last function, I got 2 functions are not done yet. I still don't update. So but the only file I could update is index.c, tile.c, read keywords.c. Only the .c file I could update.
Yeah, those are the only ones you're changing, so that's fine.
Yeah, but are you okay with I can like change the index.o?
Yeah, I'm not going to use the index.o, so it doesn't have to be updated.
Okay, thank you. It's
Okay.
weird. Yeah, I can like figure this out. Yeah.
Okay.
Thank you.
All right.
Appreciate it.
Talk to you
Thank
later.
Talk to you later.
Bye. All right. Bye.
Bye.